I think we gotta watch the introductory. Yeah, birds. That's it. That's it.
That's right, birds.
So when my son was when he was young, he used to be really into Star Wars. Big time into Star Wars. He loved Star Wars, and he used to like Legos also, playing with Legos. Anybody play with Legos?
Oh, yeah, I used to like younger.
Right.
Yeah.
Legos are awesome.
I remember I used to challenge my brothers and sisters to see who could build the thing first.
So check this out. He used to be really into Legos and Star Wars. So I'd take him to the toy store, and I'd buy him the different Star Wars Legos. And the biggest one we bought was the Millennium Falcon. Star Wars Lego pieces is like 1,000 or something, 1,000 pieces. And when you play with Legos, you can make all kinds of different structures. The Millennium Falcon, the Star Destroyer, this and that and this. But if you take a Lego, like a structure, like say the Star Destroyer, we build a ship, me and my son built it. He drops on the floor and it shatters into a lot of pieces. The individual Lego is the piece that makes everything else up in Lego world, the individual Lego. In one sense, what I'm going to cover right now is like the individual Legos of all geometry. In other words, the building blocks. Okay, the building blocks of all of geometry. So, we're going to get into some deep geometry before the week ends, because you're Math 2 students. So before we get into the deep geometry, I got to get into the basics. The first word that's there, it says undefined terms. That sounds kind of weird. Undefined terms. Something that's undefined does not have a definition. So, what would be something that doesn't have a definition? That's kind of strange. Here's the reason why. It's kind of like the starting point. If we're going to think of a body of knowledge, if we're going to create a body of knowledge and start defining things, we have to have a starting point of words that define everything else. For instance, what's the definition of a cat?
I think we said the opposite one.
Maybe you could say an animal that goes meow, right? Or a feline that lives in modern suburbia. Okay, so the cat, the word cat, it's coming off the top of my head. A feline, dot, and we can define it. But then I ask you, what's the definition of feline? Okay, at that point you say a cat, you see the problem. You're using this term to define that term and using that term to define this term. Sooner or later, where's your starting point for every word that you know? Like how would we define the word Because we keep using the word to define stuff. What's Or the word the. So where do we start if we're going to create a body of knowledge philosophically? Where do we start? Where do we begin to define things?
Get rid of it.
Get rid of what? Thank you, Soto. For that enlightening idea. My point here is we have to have a starting point to build everything else in geometry. And what I'm going to get into is, like I said, the individual Legos. And these individual Legos are used to define everything else in geometry. Okay, so I'm going to write the building blocks of geometry. That have no formal definition. but are used to define everything else. It's like the starting point of our thinking in geometry. They're undefined. They don't have formal definitions. They're like our starting point ideas that we use to define everything else. It's very philosophical. It's very philosophical. And those three, and so the undefined terms are, ready? Going to put an arrow to point, a line, and a plane. There's just three of them. These are your undefined terms: a point, and a line, and a plane. Now, a plane is not an airplane. I'm going to go over what a plane is. It's on the other side of the paper I just gave you. But a point, a line, and a plane are your three undefined terms, your starting points in geometry, your undefined terms that we're going to use to define everything else in geometry. Think of a shape. Think of a shape in geometry. What's the first shape that comes to your mind, Miss? A square. A square is defined as four lines that are coplanar. The word plane is in it, and whose angles add up to be 360 degrees. So I defined a square using these three words. Four lines that meet at 4 points that are coplanar. A triangle. Three lines meeting at three different points of intersection that are coplanar. So everything in geometry, I use these words to define it. It's like the starting point. Okay, now flip the page over real quick. You're going to see a picture of a point, a line, and a plane. Look what you see here. You have a point, you have a line, and you have a plane. This is for you to keep. This is for you to refer to when you're on your next assignment or this week's test. So let's read about it. A point has no dimension. A dot represents a point. So whenever we want to talk about a point, we just represent it by a dot. We represent it by a dot. It's not actually not the dot. It's not actually the dot. It's the dot just represents a point. Let me explain. As a point has no dimension. I like how you're thinking already. Ioanowicz is saying that it's nothing. What does dimension mean? Ioanowicz? It gets very philosophical now. Watch this, Soto.
They're like the definition of like you define reality. Like they're basically realities.
Okay, so our perceptual reality is in three dimensions. You and I exist in a three-dimensional reality. When I say three dimensions, when you look at me, Rodriguez, if you look at me, I know you don't want to. Watch this. If you look at me, I have three dimensions. I have length, I have width, and I have depth. 3D. A flat surface, look at a plane. Look at a plane right here. A flat surface only has two dimensions. It only has length and width, no thickness. Imagine something infinitely flat. Just length and width. So it's just a flat surface. So that'd be two dimensions. Like a paper. A paper would be a good illustration. But even though technically paper does have some thickness, but a paper is a good representation. I like that. So this would be two dimensions. But three dimensions, length, width, and depth. Now imagine something having no dimensions. Okay, so that's why Jovanovic was thinking, oh, it's nothing then. So if something doesn't have dimensions, does it therefore not exist? How about truth? Does truth have dimensions? Does truth exist?
Yes.
Truth exists. So truth doesn't exist?
True?
Yeah. Does truth exist? How about love? Does love exist?
Yeah. Love is a matter of perspective.
So I'm not asking what it is. I'm asking, does it exist? It does exist, but does it have dimensions? Does it have length, width, and depth? Can I measure love with length, width, and depth?
Oh, that's it.
Let's see who's on the phone here.
I agree with that.
Yes. The question is, though, we're dealing with some philosophy now. If something exists, does it have to have dimensions? Is my question to you.
I don't have to.
Okay. So a point then. So
Wait, never mind. Going back to
Well, like, I guess.
wait, let's go Soda first. Go ahead, Soda.
you're talking about yourself, right? Like you have dimensions.
No, before you answer the phone, I was asking, does love exist? And I think everyone says
To some people.
Let me finish. Take turns. I'll let you talk. Most people say that love exists. Okay, if you disagree, that's fine. I'd like to hear your arguments. I don't really care if you agree or disagree. But there's a lot of things in reality that we say exist but have no dimensions. And what I'm trying to say is, look, a point has no dimensions, but it exists. And here's how it exists. It's pure location. So, look at the tip of my finger. The location in space right there is the point. You can't measure it with a measuring tape because it doesn't have any length, width, or depth. If I were to get a measuring stick, that location right there is a location in space. That's what a point is in geometry.
I like your TV example.
Thank you, Soda. Cool. I'm glad you liked it. Now, the thing is, are you getting my communication here about no dimension here?
Yeah, I get
That's
it.
what's okay.
Come on, use space.
You can argue that things without dimensions don't exist. You can, like, love, there's some people don't believe in love. You can argue that it doesn't exist.
Right, but I like to
Some
hear the
people,
arguments.
Exactly. That's why.
You can argue,
I
but
don't know, because I don't, I mean,
That's
I
why
guess
it
I don't
shows
believe
that.
in it, but you can probably disprove it. Probably either way.
you could disprove it.
Love isn't I mean, is it a fact? But it exists, is it?
Well, that's a different question. We'll say that's a great philosophical debate. I don't want to get sidetracked, but that is something worth pursuing. We'll talk about that later. So right now, you need to know that a point is just pure location in space. So on your note guide right here, go to put pure location only. So there's a location right.
Hey, Rocky, then-
Watch this. Hold up. So there's a location right here. There's a location right there at the tip of my finger. I took my finger away, but there's a location there. That's what a point is in geometry. Now, look at the next undefined term is a line. A line has one dimension.
Yeah, pause it for a second.
Sure. Hit it. Location. Really?
Put an N.
Yeah.
Oh, it's O and N. The N is kind of like cursive attached to the O. Stop making fun of my writing, Soda. It's too early in the morning on a Monday and you're making fun of my writing already?
Where did you see it? Oh, I don't even see
All right,
it.
let's continue. So watch this. Okay. Shh. A line has one dimension. In other words, imagine pure length, just length. No thickness, no width, just pure length, infinitely extending. That's what a line is. It is represented by a line with two arrowheads. The arrows represent that the line goes on forever.
Oh, and don't have one, it just stops.
When it, between dimensions.
Wait, one at a time. Let's go one at a time.
It does have an arrow, it just stops right there.
Right. When it doesn't have an arrow, it's actually one of these. It's a line segment. You see it has endpoints. That's down at the lower end of your paper. You want to, Mitch? Go ahead.
The three dimensions doesn't really mean like they're infinitely, like something that's one dimension, I mean two dimensional is really stronger than one dimensional.
Stronger?
Third, well not stronger, but I guess.
So what would be something that's two-dimensional?
Stick figures.
We can't perceive. I mean.
Well, it's right here.
perceive.
It's right here. The third undefined term is a plane. Look, it has two dimensions. Because look, it's length and width only, just surface, flat surface. So we go from 0 dimensions, pure location, to 1 dimension, which is just a line, and now 2 dimensions is a flat surface.
Question, can you work with a square?
Say again?
Can you work with a square?
Right, a square would be a two-dimensional figure because there's no thickness, it's just length and width. So look at, I'll draw a square.
Draw a cube.
Cube would be 3 dimensions then.
A cylinder.
3 dimensions.
What the fuck is these?
So what's important right now is, let me talk, Birds, let me talk. 0 dimensions, 1 dimension is a line, and if you ever want to talk about a line, all you can do is spot out 2 points on it and then name it the way they did right here. We can call it line AB. Notice they just named it by 2 points, AB, with a little line symbol above it. Or you could call it line BA, it doesn't matter the order. But if you want to talk about a line, you use a AB and a line symbol above it. I trust you can see that on the copy I made yours. This is how we name lines.
You know what's funny? What? In grade 6,
Huh.
that football face like 2 years ago.
Sweet.
I remember.
Sweet. Watch this now.
I did that shit like 4 times already.
Watch this, Soda. A plane has 2 dimensions. It is represented by a shape that looks like a floor or wall, but it extends without end. It extends infinitely. So you need to know that a plane, even though it looks like a flat surface, a real plane in geometry goes on forever, extending infinitely. Okay?
Does it really?
In the mind, yeah.
Plane guys out. Apart.
Say again?
Apart breaks. Plane guys out.
Wow, that was awesome, Soda. Hold up. So on your notes, collinear points. I'm going to write, look at the word co. Co means together, like co-ed, company, corporation. The prefix co means together. The word linear, it's got the word line in it. So collinear points are just points on the same line. What about that? Very straightforward definition. Example. I'm going to draw a line. P, Q, R. I'm going to write PQR. R collinear. Because PQ are on the same line. That's all collinear points means. PQ are collinear. They're points on the same line. Real straightforward. I'll write that down. Coplanar points. Well, that's just points on the same what? What do you think that means? Collinear is points on the same line. What do you think coplanar means? Points on the same plane. So let me draw a plane. I'm going to put an example. Draw like a flat surface, like a tabletop. I'm going to put X, Y, Z. X, Y, Z. We'll put points X, Y, Z are coplanar. For defined terms, go ahead and cross that out. wake up.
It's good. Well, I actually was extra morning too. Like every time you write, like you just like you block me.
So you just fall asleep?
Yeah.
Cool. Don't worry, I have it recorded, so it's gonna be okay. So line segment or segment, going to put C other side. Let's finish strong, Soto. You got this.
That's what I'm trying to do, but you like can't move my seat
That's a great idea.
for a little bit.
That's a superb idea. Hit it, hit it. So line segment or segment, go and see the other side. That's already defined for you on the picture on the other side of your paper. Endpoints, cross out. There's no need to define that one. Array, see other side of your paper. It's defined and you have a picture of array there. And opposite arrays, see other side. It's defined and you have pictures of opposite arrays also. Intersection though I want to talk about. Intersection is the points in common when two figures meet. The points in common when two figures meet. Oh, man, sorry. So when two figures meet in space, the intersection is the points that they have in common. Let me explain. Actually, I'm not even going to explain. I'm just going to show you a picture. Watch this. Put your seatbelt on. Look at this. What's intersecting here in this picture? What's intersecting? What kind of structures in geometry are coming together here? Two planes, huh? Look at the plane. Look at plane ABP. That's the plane going sideways, horizontally. And plane QBA is a plane going vertically up and down. They're meeting on a line. Their intersection is actually a line. Look at the line AB. So the intersection here would be the line AB. That's the intersection of the two planes. That's the points the two planes have in common, is all the points on line AB. That's what an intersection is. So the intersection of two planes is line AB. How about the intersection of two lines? Let's see here. Look at the intersection of two lines. What's the intersection of two lines going to be? What kind of structure?
Okay, when you mean structure, what do you mean by that?
Points, lines, or planes. The intersection of these two lines is a what? Is that a plane? Is that a... That's a point, huh? So two lines intersect at a point. Two lines intersect at a point. Two planes, though, intersect. Look at this. Two planes intersect at a line. notice that. Two planes intersect at a line. Two lines intersect at a point. Okay? So that's all intersection means, is the points that are in common. So here, these two lines intersect at point P. Right, right. So two one-dimensional objects will intersect at a zero-dimensional object, namely point P. How about a line and a plane? Watch this. What would a line and a plane look like if they intersected? Check this out. It's right here. Here we go. Look at line QP is intersecting the plane BMR, this plane, right here at point P. It's intersecting it. So the intersection would be point P of line QP. Line QP and the plane intersect at point P. That's all intersection means. It's what are the points in common between the two structures coming together. In this case, the point that the plane has in common and the line has in common is point P. They share that point. They're meeting at that point. Let's finish this video and we're done.